Hello and welcome. Today we're going to talk about how to make a vector-like dynamic array in base C. Link down below, you'll be able to find this GitHub repo. And if you listen to the video and you just want to use the code, great. It's under the MIT license. If you want to follow along with the video, then before cloning the project, you may want to click on main and then tutorial start. That being said, there's not a lot of code in here, so if you're on Windows and you want to use Visual Studio, just start a new Visual Studio project and you can work from there. One last thing before we really get started, I would like to ask if anyone finds any problem or just some way to improve the code in general. Send a pull request, drop a comment, and with that, we'll go ahead and get started. Okay, so I'm going to do a little bit of chalkboarding here for a bit. So I assume that anyone watching this video has used a base array before, something like this. Maybe you have an array of ints, and we'll give it 5 ints inside of it. The good thing about this is that it's very memory efficient. If you know how many elements you need, this is great. The downsides of this can be if you want to pass it into another function, that function might not know how big this integer array is. So you may have to pass in another argument, and then that gets a little cumbersome. You also may decide later on that you want to resize this at runtime. And in that case, you run into an issue because you can't. Now in C++, in the standard library, there is a vector that you could use. And it's a great tool. One thing is that it does use templates for passing in the type to the vector. And just for the fun for this video, I wanted to think of a way of writing this without using templates and without using macros. Okay, but before we jump into code, I want to explain how we are going to be doing this. So one of the things that I was trying to be able to use was the normal way of accessing a array. I wanted to be able to make an array like this. Array, square bracket, I, if it was in a for loop, or if you're just accessing it, maybe you pass in 2 to get the third element, and that would access it. So this is what I wanted as the result, and with that, we need to have a type. I think what we're going to do is like a double, but you could have any type. You could have even like structs if you would like. So we'll have a type. We'll have the variable, and then we're going to have a pointer. That's how we're going to declare this. And this pointer will point to the beginning of the array. Now, since we're going to need to be resizing this potentially in the future, we need extra information. We need to know, let's say, how many elements are currently in the array. So we'll call that count. We need to know the capacity of this array. And we need to know the size of each element. So we will creatively call that element size. Now, why do we need to know the size of the element? Well, the reason is, since we're not using templates, we don't know the type. When we are resizing, when we're adding elements to this dynamic array, we have no idea what's actually there. When we're doing find, we're trying to find an element in the array. We don't know what we're looking for. We don't know if it's int, a float, a double. All we know is the amount of memory. So we need to know those 3 variables, but we also need to know the start of the array. And so how we're going to do that, let me get a new sheet here. What we'll do is whenever we initialize the array and ask the operating system for the memory for this array, we're first going to ask for a unsigned integer, another unsigned integer, that will be the capacity and the count. We'll then ask for a variable called size t, of type size t. That's going to be the size of each element. And then we are going to ask for a block of memory that is the capacity times the element size. Kind of ran out of room here. And after we initialize this, we're going to return a pointer to this. This will be kind of interesting. Outside of these functions for working on the array, initializing, adding elements, clearing, finding, those kinds of things. Outside of all that, we're just going to have a pointer to the data, and we can work with it like a normal array. That'll be very nice. But whenever we need to use these variables, we will pass in a pointer to the pointer, and we will shift over to the left so we can access these variables. So even though the pointer that we always store is to this data, because we know the spacing in memory of these three variables, we could just move our pointer over to look at those, to access them, to change them in the future. Okay, so now that we see how the variables of this vector will be laid out in memory, you may want to save this point in the video. And if you get confused while you're going through the functions later, you may want to come back and look at this while we're having to shift the pointer back and forth to access certain parts of our vector. But without further ado, let's jump into the code. Okay, well, here is the start of the project. Now, if you're using the code from GitHub to follow along, just some recommendations. You can use Visual Studio Code on Mac, Windows, or Linux. You'll need some sort of C++ compiler installed, and then you should look for the C++ extension pack. It's going to include IntelliSense as well as CMake tools. And it's just a plugin to communicate with the version of CMake on your desktop, and that will help configure your project so that we don't have to do too much specific for any one platform. So hopefully you'll be able to follow along no matter what operating system you're using. Again, if you have any questions getting this set up, hit me up in the Discord link below or in the comments, and I will try and get you fixed up. Just a quick example. We're going to give this a run to see what happens. So it prints out 0. We have initialized a normal integer array with 5 elements. In the first element, I set its value to 0 and then printed out that value. Now, like I said, this is good if you don't need to expand this array. But as we want to make an array that can change in size, we will be adding our code down here under the numbers variable. So the first thing we're going to need to do is initialize our array, and in that drawing that I did, we're going to need to ask the operating system for that memory, for those 3 variables and the 1 array. For that, let's go into the vec header file. It's under the source folder. Now in here, we're going to write extern void, and then I'm going to say vec underscore init. For all these functions that operate on our vector, we will write vec underscore in front of them. Now, the first argument we're going to be taking is going to be a pointer to the variable which is pointing at our vector. So we'll say void. We're using void here because we don't know what type it is. So this will let us get around that. And the second variable we're going to be taking in is the capacity. We will take this as a unsigned integer. Just a naming convention that I like. I like all of my function parameters to begin with a underscore, but you could use whatever naming convention you would like. And lastly, the size of the variable. We may just type these in one at a time. So now let's go over to the implementation file, and we're going to type out this first function all the way. The other functions, I may paste the code in and then just talk about it to help with time. So first of all, I would like to have a structure to hold the three variables. So we'll have struct, and we will call it vec info. And inside of vec info, it will hold our unsigned int for capacity. It will hold the count. As well as the element size. Okay, now we're ready to write the init function. I'm just going to grab the function over here. Now first, we're going to ask the operating system to allocate this memory for us. Now it will be in type of vec info. It'll be a pointer, and we're going to call malloc. Malloc stands for memory allocate, I believe, and all we need to do is pass it in a size. Now I want you to do the size in two steps. So first we will get the size of our vec info, and we will add that with the capacity times the element size. And so just like the drawing before, we will be allocating these three variables inside of vec info. We're getting the size of that, as well as the size of the array that we're building here. Now we could do an error check here. Malloc could return null for us. In that case, honestly, we probably don't want to continue the program. We should probably throw some kind of error message. I would rather crash the program here and let myself put in like a breakpoint and figure out where it's getting called from, why it's crashing, whether it's, you know, there's not enough memory in the computer, or maybe there's not enough of a single row of free memory. For example, if you're trying to allocate 20 megabytes on your Raspberry Pi, and your Raspberry Pi may have 100 megabytes free of memory, but let me go back to the little drawing board. Let's imagine that this big chunk of memory is I don't know, let's say 100 megabytes. But instead of it being open, let's say there's actually 50 megabytes free in here. It's split. Like maybe there's an integer here and a double here, and maybe there's some kind of photo in this spot, and then another couple of variables just kind of split in the memory over in this area. But we're trying to ask for a 20 or 30 megabyte section of this. Well, there's no continuous, so that means maybe through this area there's 5 continuous bytes, and through this area there's 15. And if we went through and added them all up, sure, there's enough for us for our 30 megabyte array, but we need that to be all together without any other variables inside of it. So if we called malloc and we asked for 30 megabytes in this area, it would say no. So looking back here, this is how we will handle our error. We will check to make sure that info is not null, and we will print out a little failed to init vector message and give the exit code of 1. For a normal process, an exit code of 0 would show that the process was good and closed well. Any other exit code would probably lead someone to believe that something went wrong. And in your project, you could choose and you could say, number 1 is for failing to allocate memory. Number 2 is for failing to open a file, and you could have kind of a breakout of what the different numbers mean for you. I'm just going with 1 for this little project. Now that we're here, we know that we initialized our memory correctly. We're going to want to set the value of our pointer to be the beginning of the array. We'll take our ref vec, but we'll need to cast it to something first. We're going to first cast it to a void double pointer, and I'll explain this here in a second, and then we're going to dereference it. So we're basically turning it into just normal void pointer. And we could stop here and talk about that for a second. Okay, so in our main file, we have our variable numbers. And if we were to pass this pointer, this pointer is currently pointing at some memory address. I think by default it's pointing at null or 0. If we were to pass this into a function, and inside of that function we were to change it to, let's say, I'll just shorten it, we'll say num equals, malloc, and we allocate some memory, and we return out of that function numbers will have not changed where it's pointing at. Numbers will keep on pointing at 0. Because we didn't change where numbers is pointing, we changed where the parameter of the function was pointing by doing this. If we want to change where numbers is pointing, we have to get a reference to numbers. So basically, if numbers is a spot in memory, it's a variable, and it's pointing to another spot in memory. It's pointing at 0. We're wanting a pointer to point at numbers. That way, that whenever we want to change where numbers is pointing, we have a pointer pointing to numbers, and we can change where numbers is, which is really good. So let me open up another spot here, hopefully. So where this will end up happening is whenever the array needs to change size. So let's say the array at the beginning is pointing to 3 numbers. So let's say 1, 4, and -7. And we want to add a 4th number to this array. So we need to resize it. So what we'll do is, let's say the number we'll add is 9. So we are going to make pointers point to this new spot in memory that has the values of 1, 4, -7, 9, and then for good measure, we can double the length, and we will keep those last 2 variables kind of hidden until the user wants to add more variables. This way, we don't have to resize the vector every time you add a variable, only whenever we run out of space. Either way, this is why we need the double pointer, and the reason why I'm not using it like this is because whenever I was to pass this value in testing, it wanted me to cast it, and I didn't want to cast it. I'm trying to cut down on the number of times that I have to cast with this vector externally. Internally with these functions, we'll be casting a lot, but that's fine because we write this file once, and we'll be hopefully using it way more than that. So yeah, I didn't want to do that here. So what I ended up doing is I put the word ref, telling the user to give me a reference to the vector instead of passing in like a double pointer to it. Either way, down here, now we talked about this. And by the way, if you do have any questions about this, comment below. There are several videos on YouTube that go in and talk about pointers and references. The Cherno has some great videos on it. So if you have any questions, comment, and I will hopefully see it soon and point you in the good direction. Either way, we're going to set this to info. But with pointers, we could do some pretty cool and admittedly very dangerous thing. We could use pointer arithmetic. So if you have a pointer and it's a type, if you are to add it by 1, it will move the pointer in memory by how big that type is. So, this type has 2 unsigned ints and a size t. I believe on at least my computer that is 16 bits. So it will move it over 16 bits, which is pretty cool. Which just so happens is at the correct spot for our new array. Now we're almost done with the init function. There's a few more things to go. So we're going to want to set the capacity of this function. And we'll just use the parameter that was given to us. We also want to set the current count of it. So we currently have 0 variables in here. And then we will also set the size of each element. So with that, we should be able to at least test for errors in this function. So if you save your 2 files and you jump on over to the main.c file, I already have vec.h included on my file. So if you're following along on a different editor, you may need to go ahead and include that. Next, we will call vec init, and how we pass a reference to the variable is by putting this ampersand in front of it. And let's see, for this we'll do a small test of 5 elements, and then to give it the size, we're going to use that size of function again. You could type this in manual. I would recommend against that, by the way. You see, certain types, whether your code's running on 64-bit or 32-bit, can be a different size. Also, different compilers that your code can run on could also choose to have your variable at a different size. So I would just recommend to always use size of, and it should work out fine for you. So we will do that, and then I'll print out a little message, and we'll just say init vector. Let's see, we need to put a new line here. Okay, so it ran. We haven't had any errors. Now, if yours didn't compile, just rewind the video and you'll hopefully spot something that might have caused it to not compile. Also, check the description again. If someone comments that on a certain compiler there's an error with my code that I haven't seen, I will pin the comment and put it in the description as well. So check that if you're having any errors and it's taking you a while and you're not really seeing a problem. So try that out. There may have been an issue with a certain compiler. Either way, we are going to write the add function. Now in C++, this is called pushback. So if you want to call yours pushback, go right ahead. The first argument again will be our vector. Then we're going to want a pointer to a value to add. And I'll copy this again. Now first we're going to start with just adding the variable into our vector, and we'll test it, and then we'll come back, and if we try to add too many variables, we will resize our vector. So first up, we're going to need to know things like the size, the current count. Is we are going to get a pointer to our info again. So we're going to get our pointer ref vector, and we're going to cast it. We could cast this to a void double pointer, but instead we're going to cast this as a vec info double pointer. And by the way, we need to dereference this. We both know that this at this spot is not vec info, it's in front of it. But by casting it as vec info, if we minus this by 1, not 12, make sure it's 1. Like I said, this can be a little dangerous. By minusing it by 1, we are going to shift the pointer and point it at the correct location. I guess I'll right here say check if array, well, we'll call it vec needs to grow. We'll come back and do that. Now we have a pointer to the value that we're wanting to add into our array here, and that's all good. But since we don't know the type of the value, we're going to need to use the function memcopy to move whatever information is at that value, is at that pointer, and move it into our array. So the first argument of memcopy is where we want to place this value. We're going to again be doing a little bit of pointer arithmetic. We know how to get the size of our current array. We can get info count, that's the number of elements currently in the array, and we can multiply that by info element size. But we need to find where the array starts so that we can add the size to it. And by the way, this is in bytes. What variable do we have that is 1 byte? It is a char. And so what we're going to do is we will be casting our pointer to the beginning of our array to a char pointer. And what this is going to do is, again, by following pointer arithmetic, when we add how big our current array is to the position of it, and with it being a char pointer, it will move that many bytes over, and it will point to where the next element in our array should go, which is pretty freaking cool. Next up, it wants a pointer to the value that we want to be copying into our array. So we will say underscore value. Lastly, memcopy needs to know how many bytes it's supposed to be copying into our array and from the value. As you can see, we are telling it something about a char pointer here, and we're giving it a void pointer here. So memcopy has no hope of knowing how many bytes to be copying here. Luckily, we do have that value in info. And then lastly, before you leave the function, make sure and add 1 to your count. If you don't do this, it's just going to constantly be overriding your first variable. So make sure you do this. This could cause headaches. Also make sure to put a semicolon there. Anyway, now if you did try to add more than 5 elements into this specific array, it would break, but we'll fix it later. Let's go ahead and test what we have so far. So if we go into main.c, we'll come down and I'll write a for loop to load up our array. We'll start with 0 while I is less than 5. Let's see, I++. Now, being that this is passing in a pointer, we need to make sure the type is correct. In other spots in C++, you can take an int and pass it into a double, and it may give you a compiler warning, but it's probably going to be fine, right? Here, it will not be fine. It will copy the memory behind the integer. And if that is owned in your program, you'll get random bits. And if it's not owned by that program, it might cause a blue screen or some sort of crash. So we'll have double num, and we will set that equal to I plus 0.5. That'll get us some double that we could be using for this. Then we will call vector add, again the first argument being our vector. Now some of you might be asking, would it be safer if at the top of these functions we were checking to see if numbers was not equal to null? And that would be correct. So if you would like to add that, go ahead and add it into your function. You could also check for things like making sure that the pointer that we're passing in to vec add is also not equal to null. So you could do things to make this a bit safer. Anyway, so that's adding it up. Next, we will write, just to test it out, we'll write a for loop to print the value. Let's see, we'll do %lf and then get a new line, and then we'll be passing in our number. Hopefully all goes well. Yeah, there we go. So we initialized our vector, we added data into our vector, and then we printed it out. The really nice thing here is the fact that we could use this like a normal array. Okay, so let's jump back in here, and we will write an if statement and check to see if our vector needs to grow. So if count is greater than or equal to the capacity of our vector here, then we need to grow before adding anything to it. The first thing we'll do, and this is extremely up to you, we're going to take our capacity and we will set it equal to capacity times 2. This means that every time our array gets full and we add something else into the array, we'll be doubling the size. Now at smaller array sizes, this is great. At larger array sizes, this can get dangerous. This is where you can go from, I need half gigabyte of RAM or thereabouts, to I'm now taking up a gig. You might want to make it 1.5 times the current capacity, but either way, we'll do it 2 for now, and if you want to change it on your end, go right ahead. Unlike malloc, which is for allocating a new piece of memory, there's another function that we could use called realloc. It's for reallocating memory. The first argument is a pointer to the current set of memory, so that's going to be for us info. Next, we're going to need the size of this new vector. So just like in malloc, we're going to get the size of vec info, and we're going to add that to the new array. We'll get the array by saying info capacity times info element size, and that should fix us up. Now again, we should be checking for if this is null. So I'll just grab that check up there and we'll place it down here. I would suggest, let's change it from a init vector to failed to resize vector. And lastly, very, very important, this refvec is currently pointing to, I should say potentially. Now, it's potentially pointing to the wrong memory. Now, the reason that's potential is in the case where we ask to reallocate and there's enough memory to the right of our pointer, it won't move our memory. It will just give it an extra bit on the end. So info could stay the same, but in most cases it probably won't. So we definitely need to be careful here. So we're going to get our reference to our vector, and we're going to set it equal to info, which is at the beginning of our vector, and we're going to point it to the beginning of the array. So there we go. Now we should be able to jump back over into the main function, and instead of adding 5 in here, we could add 10 and come down here and we could print out 10. So let's test that out. I'll make the terminal a little bit bigger. Sweet. So now we are dealing with 10 variables. This meant that this resized fine. By the way, if in here you're getting a bunch of zeros at this point, or you're getting some long random numbers, if you're getting the long random numbers, you may have a problem with how you are reallocating the memory. If you're getting a bunch of zeros, and that's been happening since you started on the add function, you may not be passing in a reference to a number. So check those things out. And again, you can ask questions in the comments, or better yet, the Discord, because in the Discord, you can post photos of your console and the code, and I can help you out with that. Either way, this is the start of a vector class. I'm going to go ahead and copy in a couple of small functions here that will help to round it out, and we'll talk about those. So let's jump into vec.h. Okay, so add a couple more functions in here. First of all, since we're dealing with dynamically allocated memory, you need to make sure and free that memory whenever you're done with it. You want to free the memory, or you'll have a memory leak, which is not good. Now the difference between free and clear, what clear will do is it will set the current count of the array to 0. So it won't change the size of the array, it won't reallocate memory, it will just set to 0. This is a fast way of, if you're using your vector as some kind of buffer to maybe each frame do some math on, then you could clear it out, and that clear will be about as intensive as a function call, casting the pointer, and setting a integer. So very cheap to clear the array out. Of course, we already had the add function. Vec count, you could call vec count to see how many elements are in the current array, which would be good to use in like a for loop, instead of us typing in 10, which may or may not be correct. You could use count. Either way, let's look at the code for these functions. In our vec free function, we are moving over our pointer to the beginning of our vector, and we're going to pass that pointer into free. Now, after it's freed, we want to make sure and set the value of our pointer to null, just in case we want to check it outside of it and make sure that it was actually set to null correctly. Over to clear, like I said, we're just setting that count value to 0. And then that count just returns the count value. So let's go rewrite our code in the main function to take advantage of these 3 new functions. So first of all, we are going to keep 10 here because we're trying to resize our vector. But here, where we are reading from the vector, let's go ahead and you could put the vec count here, but that would be 10 extra function calls, and since we know that this for loop isn't going to be changing the size of our vector, what we could do instead is we could say unsigned, I guess we'll just do count. So we'll set count equal to vec count and pass in a reference to our vector. And then we will change 10 to count. Let's throw in a clear. So I'll print out then we'll call vec clear, pass in a reference to our vector, and we will just print it back out. And then lastly, we will free our memory. And we'll run that and make sure it's all working. Oh, what's wrong? Oh. So here, just need to take away the type. That should fix it. Okay, sweet. So we printed the array the first time. We then cleared it. We tried to print it again, but of course there was nothing to print. Or at least we're not showing any active variables to print. And then we freed our memory. So that was good. Now, if you want to see an error thrown, like if you were to try to, let's say, free this twice, that should give us an error. Yep, we got a seg fault. So that's another thing. When you're dealing with dynamically allocated memory, once you've freed it, until you initialize new memory with that pointer, do not free it again, or you'll get a seg fault. Now, if you're wanting a part 2 to this video, comment below, because I could show you how to add different sorting functions, how to tell it to sort either in ascending or descending order. We could look at different sorting algorithms. And if you have any function requests to add to our vector class here, comment them down below. But I can go ahead and show you it running. I asked it to sort in descending order. Then we asked bubble sort to flip that to put in ascending order. And then use merge sort again to flip it back down. So if you want to, that code is already put on the GitHub. If you want to go ahead and read it. It's just implementations of very popular sorting algorithms. But if you want a video on that topic, comment below. And I just wanted to say thanks for watching. I'm currently developing a tower defense card game written in C++. So if you're interested in that, check out my last devlog where I talked about it. I'll be making devlogs in the future, as well as tutorial topics similar to this and around game development in general. So if that sounds interesting, please subscribe, like, ring the bell. Also have a Discord if you have any questions for me, like I've said several times in the video. But I hope this has been a educational video for you. If so, I hope to see you next time.